Welcome back, Dragons. We're on to Activity 2.3, Parts of Algebraic Expressions. Now, we did work on this previously, and I'm not entirely sure I agree with Carnegie on some of the way it expresses this, but in your interactive notebook, on page 6 in quarter 4, we did talk about parts of an expression, and we color-coded, we annotated nicely. So the coefficient comes in front of the variable. It's the coworker. They need each other. This is like saying 4 W's. Here is your operation separating the two terms, this being a term and this being a term. Try not to think of the 4 and W as two separate things. They need each other. They're a married couple. They're not going anywhere. And this is a constant here. This is unchanging. The W could change. That's why it's called a variable, because it can vary. Now, we annotated thoroughly here where we indicated who our terms were, and we even went to the trouble of adding the opposite. And we did that because later in the unit we're going to do something called combining like terms. And if you subtract something versus adding something, you're doing two very different things, and it would affect the value dramatically. So I'm going to show you what Carnegie says in Activity 2.3, but I don't entirely agree with Carnegie. And I know some of you in 6+ are giggling right now. Okay. As you learned previously, an algebraic expression contains at least one variable and sometimes numbers and operations. A term of an algebraic expression is a number, variable, or product of numbers and variables. So they mean like number, like 5, or variable, like x, or product of numbers and variables, maybe 6y. Now, here's where we're going to disagree. Consider the expression 3x plus 4y minus 7. The expression has 3 terms. I agree with that. There are 3 terms. 1, 2, 3. The operation between the first 2 terms is addition. Correct, I agree with that. And the operation between the second and third term is subtraction. I agree with that. Here they say the first term is 3 multiplied by the variable. Okay, so you got a coefficient and a variable. The second term is 4 multiplied by the variable y. Coefficient, variable. The third term is a constant term of 7. What do you think I'm thinking? I'm not so sure I would call that constant 7. If we were to proceed with add the opposite, which is pretty standard for operations with integers, we would technically have what kind of 7? If you said a negative 7, I agree with you. So this really could be rewritten as 3x plus 4i plus a negative 7. This is very negotiable here because Carnegie doesn't teach it this way. Now consider these two algebraic expressions, 8 plus 5x and 8 minus 5x. Identify the terms in each algebraic expression. Well, to me, there's an 8 and a 5x in the first expression. And for me, in the second expression, I feel there's an 8 and a negative 5x. But Carnegie feels that it's the same. And what I mean by that is Carnegie feels like each one has an 8 and each one has a 5x. I feel that this one is a negative 5x. Because if we go in there and we do add the opposite, we really have changed the value of that x. Now, if we keep it originally, identify the operation between each term in each algebraic expression. Obviously, the first one has which operation? Yes, addition. Let's compare that to the second algebraic expression. It began as subtraction. What is the same in both expressions? Well, I will agree that the constant is absolutely the same. Carnegie leads us to believe that the 5x is a term that is also the same for both. I'm not so sure I agree. What is different in the expressions? The operations are definitely different. And because the operations are different, because we have addition versus subtraction, I'm going to put an asterisk here. What happens in the first term is we stay a term what happens in the first algebraic expression is the term stays 5x. What I feel happens in the second algebraic expression is that now that second term is a negative 5x. I hope you're seeing the difference. Carnegie is saying that they both have 8 the same and they both have 5x the same. But this one's addition and this one is subtraction. So here you're taking away this value. You're making whatever this is much smaller, whereas in this one you're making whatever this is much bigger. It affects the value. Let's proceed. Identify the number of terms and then the terms themselves for each algebraic expression. Let's take a look at number 1. 4 minus 3x. How many terms are you looking at? I am seeing 2. I see this guy, and I see this guy. The first term is a constant of 4. I definitely think that that is a constant. The second term, Carnegie says, is 3x. What do you think I say? That's right, I say a negative 3x. Right, B, 4a minus 9 plus 3a. What are we looking at here? How many terms? 3, correct. 1, 2, 3. How many constants? I just see one constant. That's that guy. This is 4a. This is 3a. These look unchanging. I do think minus 9 could be negotiable where we add the opposite and we change that to a negative 9. Lastly, 7b minus 9x plus 3a minus 12. How many terms do you see? 4. I'm going to go ahead and add the opposite here. If I do so, that's going to change the values. I've got one term here, one term here, one term here, one term here. From my observation, there is only one constant, and that is here. Carnegie says it's 12. I call it negative 12. If you have any questions or concerns, please email me at my DPS email address or put some questions in the comment section on the YouTube channel. Thanks.